Good morning, all of you. This is K. Ishwant from CSC Data Science Section B. Uh, Now, I am presenting the topic about the algorithm designs. In this presentation, we have to explore the algorithm design in the regarding of subject design and analysis of the algorithms. So, let's we have a glance about that algorithm design. So, algorithm design. Now we go through the introduction. Introduction to algorithm design. Algorithms are step-by-step procedures for solving problems efficiently. Designing effective algorithms is fundamental to computer science. Good algorithms optimize performance and resource utilization. Here, algorithms are the step-by-step procedures for the solving problems of efficiently. Designing a effective algorithms is fundamental to computer science, and good algorithms optimize the performance and also the. So here, algorithms are nothing but a step-by-step procedure for the solving of problems efficiently. For every problem we have one of procedures. So for every solving of problems we need an algorithm, so it is also considered as a step by step procedure. Designing of effective algorithms is fundamental to the computer science, and good algorithms are optimized performance and resource utilization. So here good algorithms can be optimize the performance and also as the resource utilization. And importance of algorithm design. Algorithms impact the efficiency of software and systems. A well-designed algorithms can reduce computational costs significantly. They enable solving complex problems that are otherwise intractable. So here we know that what is the algorithm design. Then what is the importance of algorithm design? Algorithms impact the efficiency of software and also the systems. Well-designed algorithms can reduce computational costs significantly. They enable solving complex problems that are otherwise intractable. Next, basic concepts. So what are the basic concepts in algorithms? Here, there are some of basic concepts in algorithms. So, an algorithm is a finite set of well-defined instructions. The main definition of the algorithms is an algorithm is a finite set of well-defined instructions. A algorithm finite set means in limited. So, algorithm that have a limited in well-defined instructions. Inputs are data provided to algorithms for processing. Outputs are the results produced after execution the algorithms. So, first point is algorithm is a finite set of well-defined instructions. So and inputs are data provided to algorithm. So here inputs are given to the algorithm for processing. Next, outputs are the results produced after the executing of algorithm. So these are the basic concepts in algorithm. Next, characteristics of good algorithms. Next, here correctness ensures the algorithm produces the desired output. Efficiency relates to the algorithm speed and resource consumption. Clarity and simplicity facilitate understanding and maintenance. Here, there are some of characteristics for good algorithms. We have good algorithms and average algorithms, best algorithms. So here, what are the characteristics for good algorithms? Correctness ensures the algorithm produces the desired output. Efficiency relates to the algorithm speed and resource consumption. Clarity and simplicity facilitate understanding and the maintenance. So these are the characteristics of good algorithms. Then algorithm analysis. What is the algorithm analysis? Analyzing algorithms helps compare their efficiency, and in the analysis of algorithm we need a time complexity and space complexity. Time complexity measures how runtime grows with input size. Next, space complexity access memory usage during execution. Here, in algorithm analysis, we have the two, space complexity and time complexity. Time complexity, which measures the how runtime grows with input size. Space complexity, which assesses memory usage during execution. So these are two analysis in the algorithms. Analyzing algorithms must be helps the compare the efficiency with the one algorithm and another algorithm, because of one algorithm have um, one of time complexity and another have different kind time complexity. So it can be helpful to compare the efficiency. In time complexity there are best case, worst case and average case. Space also same. Next, big O notation. In algorithm analysis we have notations. So first of all, big O. Big O notation describes the upper bound of an algorithm growth rate. It provides a way to classify algorithm according to performance. Example, O1, O log n, On, and O to n to the power of 2. Here, big O notation describes the upper bound of an algorithm growth rate. Okay, it provides a way to classify algorithms according to performance. According to their performance, a big O notation can be describes the upper bound of an algorithm. Divide and conquer. So, what is a divider and conquer? Divide and conquer involves breaking a problem into smaller subproblems. Each subproblem is solved recursively. Results are combined to form the final solutions. So here, divide and conquer. We already know that about what is divide. Dividing is means if there is one part, it can be divided into two parts or many other. So here also, one problem can be breaking into a smaller subproblems, and each subproblem is solved recursively, and then after the results are combined to form the final solution. Here, divide and conquer strategy has used in the algorithm designing. So next, dynamic programming. So what is dynamic programming? Dynamic program solves problems by breaking them down into overlapping subproblems. It stores solutions to subproblems to avoid redundant calculations. It is effective for optimization problems like shortest paths and knapsack. Here, dynamic programming. Dynamic program solves the problems by breaking them down into overlapping subproblems. It stores solutions to subproblems to avoid redundant calculations. It is effective for optimization problems like shortest path and knapsack. So it is totally about the dynamic programming. Next, greedy algorithm. Greedy algorithm makes the locally optimal choice at each step. They are simple and often efficient for specific problems. So before that we have learned about what dynamic programming. Example of knapsack. Here greedy algorithms. So what is greedy algorithm? Greedy algorithms makes the locally optimal choice at each step. They are simple and often efficient for specific problems. Not all problems can be optimally solved using greedy strategies. So what is greedy algorithm is? Greedy algorithms can be make the locally optimal choice at the each step of this in the algorithm. Greedy algorithms can make the optimal choice. Next, they are simple and often efficient for some of the specific problems only, not all problems. Not all problems can be optimally solved using greedy strategies. So not the all problems can be solved the by using of greedy algorithms. Sometimes there are another algorithms like knapsack, any other etc. So we have backtracking also. Backtracking means backtracking systemically searches for solutions by exploring possibilities. It abandons a path when it determines no solution exists along it. It is useful for problems like puzzles and combinatorial searches. Okay, backtracking. Backtracking means systemically searches for solutions by exploring possibilities, and it abandons a path when it determines no solution exists along it. It is useful for problems like puzzles and combinatorial searches. Next, brute force approach. It is also one of the type of algorithms. Here, brute force. Brute force tries all possible solutions to find the correct one. It guarantees finding a solution but is often inefficient. It is used when problem constraints are small or other methods are infeasible. Brute force tries all problem solutions to find the correct one, and it guarantees finding a solution but is often inefficient. It is used when problem constraints are small or other methods are infeasible. Next, heuristic algorithms. We have another type of algorithm, heuristic algorithms. Heuristics provides approximate solutions for complex problems. They prioritize speed over optimality, and common in AI, machine learning, and large scale optimization. Here, heuristic means it provides the approximate solutions for complex problems and prioritize speed over optimality. It's common in AI, machine learning, and large scale. It brute force is only tries to all possible solutions to find the correct one. In all possible solutions, it will use it to find the correct one. Here, heuristic means solving of approximate solutions for complex problems. Like sorting algorithms, we have some of sorting algorithms. Sorting means organizing of data in specific order like ascending order or any other orders. So sorting algorithm is the data will be must be sorted. Examples like quick sort, merge sort, insertion sort, bubble sort, selection sort, and shell sort, any other etc. Sorting is fundamental for many algorithms and data structures. Without sorting, we cannot organize the data in the specific order. So sorting algorithms are must be used in the designing of analysis and algorithms. Like graph algorithms, we have some of algorithms like graph algorithms like Graph algorithms are used for problems like related to networks and relationships. Because of in the graph problem, the one node is related with another node. Here it's called as relationship. So here graph algorithms are used in the graph problems, like examples like shortest path, digit spanning trees, prims, and BFS, DFS, and traveling salesman problem. And there are so many graph algorithms. Next, they are essential in routing, scheduling, and social network analysis. Such algorithms, there are only two such algorithms, like binary search and linear search. Searching algorithms find the specific data within a structure. Linear search and binary search are common examples. Efficient search algorithms are crucial for database operations. Here, searching algorithms are finds a specific data within a structure. If we want the position of a number in the data, so here searching algorithms has been used. Linear is for sorting, and binary is unsorted data. So here two searching algorithms are there. Algorithm design techniques. So what is algorithm design techniques? Techniques include brute force, divide and conquer, dynamic programming, and greedy methods. These are called as algorithm design techniques. Choosing the right technique depends on problem characteristics. If the problem is about a greedy method related, so we have to use the greedy method. If it is related dynamic programming, we have to use dynamic. If the program is so long problem, so we have the use the divide and conquer, because the problem is divided into sub problems. Next, combining methods can lead to more efficient solutions. So here by combining of methods, it can lead to the more efficient solutions. Challenges. So we have the sum of challenges in the algorithm design. Handling large input size can cause performance issues. Ensuring correctness in all cases is complex. Balancing trade-offs between time and space complex is often necessary. So there are some of challenges in the algorithm design. By handling of large input sizes can cause performance issues. So some of the average and small input sizes cannot cause any performance issues, but large input sizes can cause performance issues. Ensuring correctness in all cases is complex. Balancing trade-offs between time and space complexity is often necessary. Future trends. So what are the future trends in algorithm design? Development of algorithms for quantum computing is an emerging field. So here, development of algorithms for quantum computing. Quantum computing is upcoming computer generation. So development of algorithms is for quantum computing is emerging field. Machine learning algorithms are increasingly integrated into problem solving. So here, machine learning algorithms are increasing to problem solving. Research continues toward more efficient and scalable algorithms for bigger data. Here, research has continued towards more efficient for the new algorithms for big data. Conclusion and summary. Conclusion means, here overall we concluded that effective algorithm design is key to solving computational problems effectively. Understanding various strategies and other application enhances problem solving skills. Continuing innovation in algorithms drives progress across technology and science. So overall we concluded that effective algorithm design is key to solving computational problems. So we have some of computational problems. So to solve that problem, we must be need the effective algorithm design. It is a key to solving it. So and understanding various strategies and their application enhances problem solving skills. So due to the various strategies and application, it will be enhance our problem solving skills. And continuing innovation in these algorithms, it can be drive progress across the technology and also science, etc. So thank you for giving this an opportunity to discuss about the topic of algorithm design related to the design and analysis of algorithms.